Good evening, my name is Axel Timmermann and I'm the director of the IBS Center for Climate Physics in Busan. Originally I'm from Germany and I moved to South Korea in 2017. I'm a physicist, oceanographer and atmospheric scientist, so I'm interested in the climate system, how it changes under future climate conditions. So global warming is one of the big subjects in our center, but also we're looking back in the past trying to understand what were the drivers, for example, of ice ages. So our center, the IBS Center for Climate Physics at Busan National University, has about 40 staff members, scientists, students and admin team members. And our center is dedicated to understanding the climate system, how it changed and how it will change in future in case we continue to emit CO2 into the atmosphere. So I hope to raise a little bit an awareness, of course, of the issue of global warming and that we are not doomed, that it's still in our hands how much future warming we want to allow. So even though global warming is happening and it will continue, even if we cut down CO2 emissions, it's still our choice how much we will emit, because that will determine the climate of future generations. Climate is one thing, food security is another issue, so I will maybe talk tonight also about food insecurity as a result of global warming. And this is something, that I would like to raise awareness for. Furthermore, responsibility is one other subject. We can get out of this mess in some way, but it requires concerted effort, it requires action. And that's my pledge towards the end, that actually there are solutions. We are in one of the most technologically advanced countries, and Korea could become actually a leader in exporting green technology to the world if there was more investment into this technology. Okay, now we have resolved all the technical issues, I hope. Again, good evening. It's a great pleasure to see so many of you interested in the subject of global warming. I'm particularly pleased to see many members of the young generation tonight. The issue predicting weather is not, we can do it for a couple of days, but then it gets very uncertain. However, the climate seems to be something very different. So let's think about the difference between weather and climate. Weather is everything that they talk about on TV, right? They don't make climate forecasts, they make weather forecasts. So climate is something that is actually a result of many, many days and sometimes many, many years of weather data. So weather, thunderstorms, for example, snowstorms, tropical cyclones, all of these phenomena that are very fast in the atmosphere that take about hours to days. That's what we call weather. However, climate is something, we call it average weather conditions in a certain region, but we take into account the fact that we have to average over many years. For example, if we look at ice ages. Ice ages, we're not talking about weather, we are talking about something that lasted for thousands and hundreds of thousands of years. So this is a clear feature of climate. Then also global warming itself. We are not talking about the weather in 100 years from now, we are talking about climate in 100 years from now. So the long-term changes. Okay, so how does global warming actually work? First of all, let's just start with the sun. Of course, the sun is bright, it's emitting light, and the light hits the Earth's surface, and of course, it will warm up. As it warms up, it emits infrared radiation, and that infrared radiation goes back to space, and so the infrared radiation has a cooling effect. Eventually, there will be a balance between the incoming light, the radiation, and the outgoing long-wave radiation. Now, it happens that our atmosphere is very special. It is very special because it contains so-called greenhouse gases. So CO2 and actually also water vapor are greenhouse gases. What do? Let's just say light, again, hits the Earth's surface. The Earth's surface warms. The infrared radiation wants to go out to space, but these molecules, CO2 and water vapor, they prevent this. They reduce the amount of long-wave radiation that can go out to space, which means the long wave, the heat radiation, if you like, is trapped in the atmosphere. That leads to extra warming. And this effect has been around for millions and millions of years on our planet. It's a so-called normal or natural greenhouse effect. However, if we as human beings increase the concentration of CO2 in the atmosphere, we are increasing the number of molecules that have this property to trap the heat in our planet. That's why it's called greenhouse effect, like a greenhouse which traps also the heat from escaping. So we are creating a blanket around our planet, which makes actually not a real blanket, but a chemical blanket, which makes our planet warmer. Okay, let's ask a couple of simple questions here. So we know CO2 is increasing, but is it due to human activities? And well, this is showing essentially the main elements that play a role in the so-called carbon cycle. And those of you who got an ocean book, the blue book that we published, there is more information also in there. So we have the ocean, we have land, and all of them participate actually in the global carbon cycle. Now, then in addition, we have humans, we have factories that pump, factories, cars, and many other things that through industrialization pump CO2 in the atmosphere, and they create again this. And this experiment is just addressing the question, if the heat actually wants to escape to the space, but it's trapped by the greenhouse gases, the CO2 in the atmosphere, and it keeps warming our planet, where is all the heat going? Where is the energy going? Is it in the atmosphere? Anybody thinks in the atmosphere? Okay, well, we'll see. We'll do a little experiment here. So I will need a volunteer. Anybody volunteering? Oh, so many hands. Oh my God. That's going to be difficult. Me. Okay. Let's take you. No. Okay, that's fine. You're standing up already. We need 2 volunteers. How about you? Yes? And the gentleman in the blue. Okay? Okay. What's your name?
My name is Kim.
Okay, great. Welcome.
My name is Kim Junso.
Okay, Kim Yonso. Great pleasure meeting you both. So first experiment is, this is just an air balloon. You know that from your birthday parties maybe. Okay, it's filled with air. Nothing special about it, right? Okay. Somebody can hold it? Who wants to hold it? Far, far away from your body. You want? Okay. All right. So this is global warming. This is just the atmosphere. What is going to happen? Okay, well, we'll see. Hold it far away from you. Okay. Close your eyes. Oh. Okay, so clearly the atmosphere cannot store heat, right? It does not do very well. Okay, thank you very much. And a little applause. Okay, now we have a second experiment. Aha. So what's the second experiment? All right, we will do something else. I hope it works. Also, so this is filled with water, right? So I didn't, you have to hold it very tight. It's kind of heavy, I know, and hold it far away from you. Maybe you can help him also. Can you help him? All right, let's move it here a little bit. Okay, cool. And I will just try to heat it up.
No. No, boo.
And I could do it for minutes and minutes and minutes. Nothing will happen. Thank you very much. Great applause to you. Thank you. Okay, so what have we learned? Water can absorb a lot of energy. So where's the water? It's in the oceans. So it turns out that 90% of the energy that should radiate out to space but gets trapped by the greenhouse gases actually enters the oceans. And these are some of my oceanography colleagues. So they measure the heat, the temperature, and the heat in the ocean, the energy. And it turns out, if you look at this, so the temperature measurement started around 1950 or so, we are seeing clearly the increase of heat in the ocean, and it's massive. The amounts of heat are gigantic. So what happens if water gets heated? It expands. It expands, and that causes sea level rise. How do we know it expands? So everybody, of course, nowadays you use a digital thermometer when you have fever, but the good old days you had a mercury thermometer or alcohol thermometer. So you saw if you had fever, it expanded, right? It went up. So if we put so much heat into the ocean surface, the ocean volume should expand. And that's in fact what we can see. So from the space, under normal conditions, so happy, this is if we expose it to conditions that are representative of what's going to happen in about 80 years from now. Well, you see it has holes and so on. The shell is much thinner, it's not happy at all. So that's something to keep in mind. And we have prepared a video here that shows the effect of ocean acidification, of this chemical reaction, on the calcification. Calcification, coral reefs are calcium carbonate. So wherever it's green, it's okay. We can form calcium carbonate. This is present. This is 50 years, 60 years ago, or 70 years ago. I remember. Okay, and now we see time goes forward, and we are seeing it's getting orange. This is right now, not many areas left. And then about 2100, the entire ocean will be in an area, it will be exposed to chemical conditions. It has nothing to do with the warming. It has only something to do with CO2 creating a chemical reaction in the ocean. That actually means we have very few areas where calcification of a particular type of calcium carbonate, so-called aragonite, is not possible. Okay, let me just give you an outlook here. Some of you have heard about the Paris Agreement. It was a milestone agreement where about 196 countries came together, and most of them, except the United States and Syria and Nicaragua, signed a treaty which essentially reduces CO2 emissions into the future to cut down CO2 globally. And this is when 2015, that was when the Paris Agreement took place. And there was already warming here, we know that. And also the ocean acidity already increased. So drop in pH means more acidic. However, now the question is, are we doomed? Global warming is going to happen in future. Can we change the course of future? Can we change what will happen in future? Do we still have a chance to modify the outcome? And the answer is yes. Even now, even though we have created already global warming, we can cut down CO2 emissions, and we will be in a world where temperature will still be warmer than before, but not as bad. Where the ocean acidity will still be worse than it used to be, but still not as bad. Or, as we continue to increase CO2 in the atmosphere, our planet will be one where life in the ocean will be very different, where our planet will warm up dramatically. Or is this our choice? So we still, by changing the policies, by changing technologies, by changing our entire economy, we can still determine which pathway we want to take. And keep in mind, whatever we do will stay in the atmosphere for hundreds and thousands of years. So any decision we make right now on the direction, this way or this way, will actually impact humankind for hundreds of generations, if humankind survives that long. Okay, so what next? Well, we are in one of the most technologically advanced countries in the world. The fastest internet in Korea, you can find in Korea. If I go back to Germany, I'm always like, is there any Wi-Fi? Is there any? Nothing. So Korea is really amazing in that regard. So this is also a country where new ideas grow very fast. This is an area where essentially we can figure out how to use technology in a smart way to reduce CO2 emissions. Right now, the way we use energy is stupid. We waste energy all the time. Our houses are not insulated. We are driving cars that are too big to actually make sense, including my own. We are not really using the fact that during daytime we have a very different energy profile than during nighttime, and so on and so forth. By storing energy, by using battery technologies, we can become much smarter and not waste as much energy as currently. So there is a chance here, and I just wanted to say, last word here, reducing CO2 emissions has several effects. One is it can create a green economy where we actually support technological advances that drive down our CO2 emissions. That's it. And Germany has benefited from this tremendously. So Germany created a green economy. This is growing much faster than the fossil fuel industry, which is actually dropping. Then, of course, reducing CO2 emissions means great. We are reducing global warming. It also reduces air pollution, misemonji. So much of the misemonji, of course, a large fraction of it comes from China. Okay, we can blame Chinese, but also part of it comes from Korea. And the moment we cut down fossil fuel burning, air pollution will drop dramatically. So this is another problem, but they're connected. And that's interestingly the reason why China is interested in reducing CO2 emissions. They don't care that much about this one, but they care about air pollution. Well, still very bad, but they want to cut it down. And they have figured out it's an economic opportunity. So this whole thing, if you do it right, can become a win-win-win game. Everybody's winning, except for the fossil fuel industry. Okay, with that, I will stop, and I'm happy to take any questions you have. Thank you.